Today we are having a question like this. A capacitor of capacitance C is given a charge Q at a time t is equal 0. At time t is equal 0, it is connected to a battery of EMF E through a resistance R. Find the charge on the capacitor at time t. Okay. So, what the question is? The question is we are having a capacitor. Okay. So, we are having a capacitor like this, which is initially charged to QO. Right. Initial charge on the capacitor is QO. Say this is plus and this is minus. Later, we are connecting this to a source of EMF like this. No? This is the actual capacitor what we are having, and here is charging resistor, and here is the battery, and we connected the capacitor like this. Beginning there was a charge QO on the capacitor, and the capacitance of the capacitor is C. EMF the battery is said E, and how much the resistance we are having? It is R. So, all these things are said in the question. I may show you something like this, you know. So, if we connect like this may yield the capacitor to charge suddenly. So, I simply introduce a switch here. Okay. So, this is the switch. So, now as soon as I close the switch, capacitor gets the charge slowly through the resistor. Well, so in this situation, okay, so if I close this switch, so how much the charge that is going to accumulate slowly, that is what we call the current. Okay, the current that is settled in the circuit is I say, right. So, slowly the capacitor gets charged. When the capacitor is completely charged, this current becomes 0. So, now what I have to do is the EMF across the capacitor at any time to be found. Say at any time t, any time t, the charge on the capacitor is Q. Okay, Q. So, by definition, what we know? So, by definition, it is capacitance is equals charge divided by the voltage. But how much is V? So, V is, right, V is nothing but Q divided by C, right. So, Q divided by C, and further what I have to do is the value of potential difference across this resistor, that is to be found first. Means the potential difference across R is I into R, right. At any time t, it is I into R. Therefore, what I can do is I into R, right, plus it is Q divided by C. What actually these two things? I am summing these two. I into R is potential difference across the resistor. Q by C is potential difference across the capacitor. Okay. If I add these two terms, so definitely I should get E, the EMF of the battery. So, what actually we know about I? This I is dq by dt, right. I is dq by dt, and sorry, I wrote V here, so it is not V, this is a C, right. This should be C. Okay. So, now we are having this much. The further what I can do, therefore, it is dq by dt into r plus q divided by c is equals e, right. So, this is the thing I am having now. Further, what I do is I simply separate these two terms because I should get the value of q on one side and all other things on the other side, right. So, for this I am simply making use of the notation like this. What I do is I simply take this q by c on this side, dq by dt into r is equals e minus q divided by c, right. So, this much thing I am having now. Now, I do what? I simply bring these things to the denominator of LHS and I take this dt on this side, okay, along with r. What I can write is dq divided by e minus q by c, which is equals dt divided by r, okay. So, this much a thing I can do now. So, now this is nothing but the differential charge is a very small amount of charge at any time t. So, that is dq. So, once we integrate this whole equation with respect to the dq and dt on either sides, so we will get something that is a total charge in the capacitor. Now, to get total charge, right, to get the total charge in the capacitor, at any time t, any time t. So, we integrate this. So, integration of dq divided by e minus q by c, right. So, which is equals integration of dt divided by r. Once we did this, we should know the limits. The beginning charge in the capacitor, what they said in the question, initially the charge in the capacitor was Q. So, you should be careful because this side of the capacitor should possess positive charge and this side should possess negative charge. So, this is Q. Otherwise, I have to write minus Q. Okay. So, initial value of charge is QO on the plate of the capacitors, right. So, it is plus QO, otherwise simply QO. The instantaneous charge at any time is Q, and we are integrating with respect to t, that is 0 to t, right. So, now what I got on this side, this is nothing but minus c natural log of e minus q divided by c with the limits what? It is QO to Q, and on this side it is nothing but plus t divided by r. Only this much I got on this side. So, now when I put the limits, right, it is minus c, and what I have to write is inside the bracket, it is ln, it is e minus q divided by c and minus ln, so it is e minus QO divided by c, right. So, on putting the limits, we got this much result, and on this side it is simply t divided by r as it is. So, now what happens on this side? So, this is nothing but natural log, right, e minus q divided by c and whole divided by e minus QO divided by c, right. So, these things should be inside bracket, and on this side it is as it is t divided by r. Otherwise, I do one thing next, that is simply I bring this minus a on this side. So, that becomes a natural log, right. It is e minus q divided by c and whole divided by e minus QO divided by c, and on this side it is minus t divided by RC. And basically we know the definition how we can write these terms. So natural log, and on this side is minus t divided by RC. I can write E minus Q divided by C, and whole divided by E minus QO divided by C, which is equals E power minus T by RC. Right. So now simply rearrange this equation as we want. Okay. So what I do is E minus Q by C is equals E into E minus T divided by RC, right, minus QO divided by C into E power minus T by RC. Okay. So now I need this one, right, I need this one. I simply take this E on that side, otherwise I simply make some rearrangements I am doing here. Okay. So when you make the rearrangement, it is Q, otherwise I do like this, you should be careful when you are doing such things. It is EC minus Q is equals, right, this is a EC E power minus T divided by RC minus QO E power minus T by RC. So now I need this one. Okay, I need this one. Therefore, Q is equals, what I can write, Q is equals, it is EC minus EC E power minus T divided by RC, and this becomes a plus QO E power minus T divided by RC. Okay, so that implies what? So now the final step is this one, Q is equals, right? So Q is equals, between these two, EC is the common thing. I can take out EC outside, and inside bracket what I can write, it is 1 minus E power minus T by RC plus QO into E power minus T by RC. So this is my final result. Okay. So this is the amount of charge is the, right, is the amount of charge charge on capacitor, on the capacitor and charging, okay, at any time t, at any time t, during charging, and you must know when t is equals 0, so we will get the initial charge. When t is equals infinity, that will give the maximum charge. Okay. So you must know it before. If t is equals 0, q is equals initial charge. If t is equals infinity, then we will get q as a maximum charge, right. So these clues you must know.